In the last video, we've had a look at what Mr. Niels Bohr had to add to Rutherford's model to make it more accurate, and up until now we've been talking about these electrons and the nucleus. But now let us go into the nucleus and quickly look at what all is inside this nucleus, and let's just fix it all together up, right? So I'll just give you a brief idea about the nucleus itself. What is it made up of, and yeah, how can you visualize the nucleus? So just like electrons were discovered because during some experiments with atoms, they got some negatively charged particles that are being emitted, and so they knew that the atoms should be made up of these negatively charged particles called electrons. So this was the first particle inside the atom, called an electron. Then furthermore, they did more experiments and they found out that there was also a positively charged particle inside the atom. Now obviously we've looked at, so let me just draw a small diagram here. This is the nucleus, and this is, let's say I just draw one electron here. This is my electron in orbit. So they knew that this atom has electrons, and now we know where those electrons are. This is that electron. They're in the orbits, the specific orbits given by Mr. Bohr. So perfect. Now where are those positively charged particles that are being observed? Well, they are inside this nucleus here. So this is our positively charged particle called a proton, and this is present inside this nucleus. So the nucleus does not have the positively charged soup. Instead, it has these positively charged particles called protons. Now they also discovered that the charge on both the electron and the proton is almost the same. So if this has you have 1 unit of charge, the proton also has 1 unit of charge. So now so they had to come up with a unit for charge, and that is also convenient to be used at such small scales, because atoms and electrons and protons are very small. They have very small charges also. So what they said that the charge on this electron, let's just call that 1, and because it's an electron, let's call that E. So the charge on an electron is 1e, but because the electron is negatively charged, let's call it -1e. And because the charge on a proton is almost equal, let's call it 1e again. E is the unit, like it's the charge of an electron, and the proton has an equal charge. So even this has a charge of 1e, but this is positively charged, so we'll just put a plus there. So they have equal charges. Now for the atom to be overall neutral, or for it to have an overall zero charge, the number of electrons and the number of protons should be equal, right? Because if the number of electrons and the number of protons is not equal, let's say I have 8 electrons, so the total charge on the electrons, the net charge due to the electrons is 8e, -8e actually. And let's say I have 8 protons, or let's say this time I have 9 protons in some atom. So the total charge due to the protons will be +9e. And if I add -8e and +9e, I get, so if I'm adding these two to get the net charge, I get, well, +1e. So this is an +1e charge. So this shows that my atom will be charged. But we know that the atom has a net zero charge, so they cannot be in this number. The number of protons has to be 8, so that the charge due to the protons will be 8e, and that's why we get no net charge. And that's why the number of, so let me just quickly write this conclusion here. The number of, I'll just write number of electrons equals to the number of protons. So just keep that in mind for the whole thing to be for this to have net zero charge. So that's the first thing. Now we also know that the mass of an electron is very small, right? It is negligible. So, and also the total mass of the whole atom is concentrated in this tiny region. So if the mass of the whole thing is, let's say, 5 units, all that 5 unit mass, most of it has to come from these protons. What scientists found out, that let's say they take an atom that has a mass, or that has a mass of, let's say, 6 units. I'll just call these units. I'm not going to get into what these units are. Let's say some atom has a mass of 6 units, but they found out that if they, let's say, looked at the number of electrons, such a thing had 3 electrons, and let me just change the color, and it also had 3 protons, because obviously it will have 3 protons because they have to be equal for it to be neutral or net zero charge. Now you have 3 electrons, 3 protons. The mass of so it is perfectly neutral, but the mass of these electrons is negligible, so let's not count them. And the mass of these 3 protons should be 3 units, right? Assuming that one proton has 1 unit mass. So what they found out, that the mass of the protons was only half of the total mass of the atom. So where is the rest of the mass coming from? If the protons have a mass of 3 units only, and the whole atom has a mass of 6 units, where is the rest of the 3 units coming from? Now obviously there has to be something else inside this nucleus that is giving that rest of the mass. So they had to come up with this new particle called a neutron. I hope this is not getting too complicated for you. Just pay attention. So they called this new particle a neutron, and this neutron is also inside this nucleus. Now, as the name suggests, this neutron is neutral. It has no charge, because if it had charge, it would make this whole atom charged, because already we have the charge balance due to this 3 electrons and 3 protons, equal number of both electrons and protons. So even if we add more neutrons, the whole thing will be neutral because it has no charge, but its mass is exactly equal to the mass of the protons. So if I have to quickly summarize the whole thing that I have just told you, let me quickly summarize. So remember, why did we come up with this new particle called neutron? Because the mass of the atom was double the mass of the protons. So protons were contributing to half the mass of the atom. So where was the rest of the mass coming from? So they had to come up with this new particle called a neutron, which was contributing to the remaining mass. So now let me just quickly summarize. I don't want the video to get too long and complicated, but yeah, let me just summarize everything here. So we have essentially 3 particles here. We have the electron, we have the proton, and these are the 3 basic particles by which every atom is made up of: electron, proton, and we have the third particle, neutron. Now this is negatively charged, so this is a negatively charged particle. This is a positively charged particle, or rather, let me just not draw this, let me write the charge. So this has a charge of not plus, sorry, this has a charge of -1 E, this has a charge of +1 E, and this has a charge of 0 E, neutral. Clear? Now the electron has negligible mass, so let me just call that 0, the mass. So here I am talking about mass, the 2 basic properties, right? Mass, and the second basic property is charge. So here I am talking about charge. So you can just take a screenshot of this when I complete this, it will be handy for you. So the mass of the electron is negligible, let's call that 0 for now. The mass of the proton is, let's say, 1 unit for now, I'll just call it 1 unit. And they found out, because the rest of the mass was coming from neutrons and only half the mass was coming from protons, therefore these two should have equal mass, right? That's how the rest of the half of the mass is coming from neutrons. So what they found out was, I'll not get into too much detail again, is that the neutron also has an equal mass almost. So now if the proton has a mass of 1 unit, the neutron also has a mass of 1 unit, but the neutron has a charge of 0 E, the proton has a charge of +1 E, and the electron has a charge of -1 E. So this is the This is basically it. So I hope, just take a screenshot of this thing and this will be handy. So the electron has some charge but no mass. Proton has a positive charge and also it also has some mass. The neutron has no charge but it has some mass equal to the proton. So that is it. It might look complicated but it is essentially same, essentially easy. So now if I quickly connect this to the diagram, I'll quickly draw the diagram. Here I have the nucleus. Inside the nucleus I have protons and neutrons, and they are generally present in equal numbers. So if I have if half of the nucleus, so the mass of the nucleus, half of it comes from the protons and half of it comes from the neutrons. So we generally have an equal number of protons and neutrons inside this nucleus. So this nucleus has protons and neutrons, and the electrons are present around this nucleus in these orbits. And let's say if I have 3 electrons, so I should have 3 protons also to keep it neutral, net zero charge. And because generally I have 3 equal number of protons and neutrons, I should have 3 neutrons also. So the mass of such an atom, where we have 3 each, all of them, we have 3 protons, so 3 units due to them, 3 neutrons, so 3 units due to them, and a total mass should be the mass of neutrons plus the mass of protons, which is the mass of this nucleus here, and that would be 3 units due to this plus 3 units due to this, which is 6 units. So the mass of such an atom would be 6 units, and it would be net neutral or zero charge, because we have opposite charges here, 3 electrons, 3 protons, that will cancel out each other. And that is basically what is inside the nucleus. We have equal number of protons and neutrons generally in the nucleus, and equal number of electrons revolving in the orbits. So that is basically the atomic structure. And yeah, that's it for this video.